Alright, in this video we are going to start getting into the different ideas behind radicals. And before we can actually work with radical equations, which is one of the places that we're heading, we have to look at where radicals begin. So we have to know how to do the basics. That starts with understanding how a radical itself is labeled. So we're all familiar with this square root sign here, okay? And we're familiar with putting the value underneath it. What we're probably not familiar with is the different definitions we have. So first and foremost, the value that goes underneath the radical symbol is actually called a radicand. And so that is any expression, be it number, variable, combination thereof, that is going underneath your radical sign. In other words, it is the part that you are trying to evaluate. The piece that a lot of us are not necessarily familiar with would be this little digit right here that is offset in what I like to call the valley of your radical symbol. This tiny little digit here is called the index. What's important about the index is the index actually tells you the type of radical symbol you have. Here in this example, the index here is a 3. What that means is that this would be called a cube root. With it being a cube root, what that also means is that in order to evaluate the radical, I would have to break my 27 down into a single group of 3 terms in order to pull anything out. Okay? So what am I talking about? Well, let's take a look here. Working with something that we're all familiar with. What if I asked you to take the square root of 25? Instinctively, we all know that that's 5. But mathematically, how do we actually get there? And yes, a lot of you would probably say, well, I used my calculator, which is most likely true. But what if your calculator breaks and you have to be able to reduce a radical? So we fall back to then, mathematically, how did we get there? How did we actually determine that 25 breaks down into 5? Well, what do we know? We know that when we're talking about the square root of 25, my index is 2. The reason I know that is because what we all grew up with learning in the very beginning is all about square roots, and that a square root essentially meant 2. Now, using that index, what does it actually mean? Well, the index actually tells us that we need to find a number that when copied the same number as your index will give you that answer. In other words, we know instinctively that when we break down 25 into essentially factors, we are looking for a perfect square. Well, in this case, we know 25 can break down into 5 times 5. So if you notice here, I've taken my 25 and I broke it down into 5 times 5. This right here is what's called a group of 2. Because I have a group of 2, the number of members in your group must match your index. If that holds true, then you can pull the value out as your reduced function. So because I can break 25 into a group of 5 times 5, it means I can pull the 5 out of the radical. Now in this case, I didn't have anything else to work with, so the radical dissolves. But that's not going to be the case with everything we look at. Now, before we really get into it and take a look at some larger examples on how to simplify, we have to keep one thing in mind. And that is, at this point in time, we have not done anything in terms of the study of imaginary numbers. Therefore, If you have a negative appear underneath your radical sign, at this stage in the game, we have to follow the basic rule that applies. That rule says, if your index is even, then you cannot take the radical of a negative number. However, if your index is odd, then you can evaluate a radical of an even or of a negative number. Okay, so that is the basic principle or rule we have to follow. Now continue on with basics. We have to be able to simplify your expressions, and if you look at just these couple examples here, you'll notice that these expressions are larger than just simply say evaluating the square root of 25. It's larger even than evaluating the cubed root of 27. Here we are mixing both numbers and variables together, and you have to be able to reduce them all. The easiest thing to do is to take your radical and break it into its parts. Make it a little bit smaller. Deal with each individual part on its own, and then just simply remember to squish it all back together in the end. So what does that mean? Well, that means if I look at this first example here, I have that I need to simplify the square root of 45 times n to the 11th. So I'm going to go ahead and rewrite this formula by breaking it into its two parts. So I've got the square root of 45, and I have the square root of n to the 11th. And I'm going to just look at them individually, and then at the end combine them back together. So when I'm looking at 45, I want to look at, can I reduce 45 down to a perfect square? Because after all, if you do not see a number written in your index, you can assume that number is actually a 2, meaning square root. So in this case, I am looking for groups of 2, and they have to be identical. So when I think of 45, the first thing that I think of is I think of 9 and 5. Well, if I look at this, I now have a group of 2, but my two terms are different. So I have to look at each individual term and ask myself, can I break this down even further? Well, I know that 9 can reduce to 3 times 3. So if you look here, I now have a group of 2 identical terms. So me personally, and this is just my personal preference, I like to circle my 2 identical terms because that tells me that I'm pulling that value out. So since I have 2 identical 3's and I need a group of 2, it means I have something I can pull to the outside of my radical. So what am I pulling out? Well, I am pulling out the 3. Thus, changing this to being 3 square root, and then what was left was the 5. So 5 goes under the radical. Now in this case, there's nothing else that I can do, so in terms of my number side, I have reduced it as far as I can. I still have to do my variable. There's a couple ways that you can approach the variable. First is going to be algebraically. Just like we broke down the 45, we can break down n to the 11. So the first thing that I would do is I would take it and I would turn it even. So I would go ahead and pull out one of my n's, and that's going to leave n to the 10th on the other side. Now again, my index here is an index of 2, which is an even number. So one of the things that I can look at is I can look at, can I divide 2 nicely out of 10? Well, in this case, I can, which means by dividing the 2 out, this side down here becomes n to the 5th. And so what I have is I can pull out my n to the 5th, because if we look at it, we would have two of them, n to the 5th, which would mean this right here is going to be my group. And so we pull that out, and that means I have n to the 5th, and then what was left behind is the square root of n. Therefore, I have to push it all back together. So to push it all back together says whatever's on the outside has to stay on the outside. So this is really 3 n to the 5th. And whatever's on the inside stays on the inside. So I've got square root of 5n. Now I said there was two ways that you could approach your variable. The second way is this, and I don't usually write this very often because it is a little bit tedious, but it says here that I have 11 n's. So I have the square root of n, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got the square root of 11 n's. So longhand, that's what I have. I have an index of 2, which means I need groups of 2. Therefore, I could go ahead and start circling them. Here's one group of 2. Here's two groups of 2. A third group of 2. 4 groups of 2. 5 groups of 2, and I have one lone survivor. So here, my groups of 2 are made up of n, and I have 1, 2, 3, 4, 5 of them. What's left behind? Square root of n. So that is the other way that you can approach variables. Whichever method that you would choose to use for most instructors is personal preference, totally up to you. But those are just two ways that you can attack simplifying a variable when you're working with radicals. So once we do it once, obviously that's not enough, so let's go ahead and do it again. I have the square root of 180 x to the 5th y to the 8th. So just like before, I have to look at my index. So I'm looking at what is going on right here. And since there is nothing listed there, that tells me that I need, again, groups of 2. It tells me I have a square root. So here, I'm going to go ahead and look at 180. I'm then going to look at x to the 5th. And lastly, I'm going to look at y to the 8th. So I'm going to break down 180, and these numbers break down many different ways. For instance, some will look at 180 and they're going to see 36 times 5. Others are going to look at 180 and they're going to see 10 times 18. And others still are going to look at it differently, and they may see 2 times 90. So however you choose to start is up to you. However, what you have to make sure that you do is that every time you break down a number, you have to try and see if you can continue to break it down further. So we want groups of 2, so you have to find identical groups of 2. And how you get there is up to you. So one of the things, like I said, that we may see is we may see 180 divided by 9. So if we see 9, that leaves 20. Notice I have a group of 2, but they're not the same. My 9 I already know can break down again into 3 and 3. And there is my first group of 2 that can pull out. Now the other thing that I know about 20 is that it also can break down, and so if I look at it, 20 can break down into 4 times 5. This is still a group of 2 here, but they're still different. However, 4 is special. It can break down into 2 and 2. therefore giving me another group of 2. So when I'm looking at 180, I can pull out a 3 and I can pull out a 2. So this says I'm going to pull out a 3 and I'm going to pull out a 2 and I'm going to leave behind the square root of 5. Well, I need to do the math. 3 times 2 is 6. So this is 6 square roots of 5. Now I need to break down x to the 5th. So again, I can break down x to the 5th into x times x to the 4th. And then I know x to the 4th is going to break down into x squared and x squared, which in this instance gives me my group of 2 and leaves an x behind. So this one is actually going to become x squared square root of x. Now the last one I have here is y to the 8th, and I need to break down my y to the 8th. So I know y to the 8th is going to become y to the 4th and y to the 4th. If I look at that, notice right here I actually have my group of 2, thus being y to the 4th. So the end result is you need to put it all together. So if I look at what's on the outside, I have a 6x squared y to the 4th. I then have a square root of 5x. Okay. So let's just look at a couple more real quick, and what I want you to notice about these is that this first one here has an index, and this index is 4. So an index of 4 says that this time I am looking for groups of 4 identical members. So again, I'm going to attack it the same way. I am going to break down my radical into the number and the variable. In doing so, I have to again attack it by simplifying my number, and this time instead of finding a group of 2, I need to find a group of 4. So when I look at 16, one of the first things that I personally see is 4 times 4. So notice this is a group of 2, yes, but my index says I need to have 4 identical members. Since each of these only counts once, I have to keep breaking them down. So 4 becomes a 2 times 2, and 4 becomes a 2 times 2, thus giving me a group of 4. So what that means is that this first fraction is going to become a 2. Now when I'm looking at the other fraction, again, one thing I could do with it is I could list out 12 ends and circle groups of 4. Or if I want to look at it algebraically, I need to break this down. In order to break it down, says that I have to do n 12 divided by 4 and look and see if that works evenly. In this case it does. This becomes n to the 3rd. And there's nothing left over. It completely divides out evenly. Therefore, my answer here is actually going to be 2n to the 3rd. Now let's look at one that maybe wasn't quite the same. Notice this next one has an index of 3. An index of 3 says I'm looking for a group of 3. So just like before, I'm going to go ahead and I'm going to break everything down bit by bit. So I have the cube root of 81. I have the cubed root of x to the 9th. And I have the cubed root of y to the 17th. So again, the first thing that I would do is I would start breaking down my 81, and in this case what you need to remember is that I am looking for a group of 3, not just simply a group of 2. So when I look at 81, immediately I see 9 times 9. So this is 2 identical members, but I need 3, so I have to break it down again. Breaking down my 9s gives me 3 and 3. Since I had 2 of them, I have to do it again. And what you'll notice is that now I actually have a group of 4. However, I only care about 3 of them, which means 81 is going to break down to being 3 cubed root of 3. I can pull my 3 out, but I have to leave 3 behind. I now need to break down x to the 9th. So again, when I'm looking at it, I want to look at what is x to the 9 over 3. Okay? So in case you didn't pick up on it the first time, when we are talking about doing this little math here, this numerator here is going to be your power. Your denominator here is your index. And essentially what you want is you want to ask if it divides out evenly. That's what you're asking. So if I do 9 divided by 3, do I get a nice result? Well, in this case I do. 9 divided by 3 leaves me with x cubed. Since that breaks down the way it does, I would pull my x cubed out and thus leave nothing behind. Now the last one we have to do is the cubed root of y to the 17th. So let's take a look at that. I need to do the cubed root of y to the 17th. So the first thing that I would ask myself would be, does y to the 17th over 3 work out evenly? Well, in this case, no it doesn't. So I have to be able to break it down. So the first thing that I would do is I would say, okay, since this doesn't work, if I factor one of my y's out, that's going to leave 16 more. So the next thing I want to look at is, does y to the 16 over 3 work nicely? Well, again, my answer is no. Therefore, I have to take y to the 16th and I need to break it down again. So I'm going to break it into y and y to the 15th. Again, I'm going to ask myself, does y to the 15th over 3 work out nicely? And in this case, it does. It becomes y to the 5th. Therefore, we have now found our answer. And this ends up being the value that comes out. So I have to put everything together. Well, finishing up this one says I have y to the 5th on the outside, but then I still have these two y's here that I had factored out, and these are left on the inside. The final thing I have to do is I have to put it all back together. So the first thing that I have is I have a 3 on the outside, x cubed on the outside, and y to the 5th. So this is going to be 3x cubed y to the 5th. My index is a 3, so this is now cubed root of, and I have a 3 inside and a y squared inside, so this becomes 3y squared. So that is everything that you need to know to get started on the basics of simplifying your radicals and working with your radicals. So if you have any questions, please let me know. Otherwise, I will see you next time.